Hello everyone and welcome. Today we are turning abstract graph theory into something you can all see. All the code comes straight from the Alam Hamis book, Optimization Algorithms. So this is the book, and mainly it comes from page, I'll say 62, blind search algorithms and introduction to graphs. We'll see how this code works, and we'll make sure that it is actually interesting and worthy. Okay, so today we are using two libraries, NetworkX and HyperNetX. Of course, pandas, matplotlib and numpy are always our friends when we're working with Jupyter Notebook. So they are here as well. We are using matplotlib inline, so the pictures are present nicely. And let's import these libraries and get a nice figure size with them. So pressing Shift and Enter, and we have them. First up, undirected graph, is where the edges have no orientation. So think about friends in a shared group chat. Pretty much if Alex can message Bravo, then Bravo can message back Alex. So how do we display this? It's graph. Okay. Graph equals nx.graph, and let's press Ctrl and Shift and Enter, and we see that nothing special is created. Graph is an object in Python. In Python, all of the things are objects, first-class citizens, so to say. So that's great. And nodes are a list of range 5. What does this mean? If we print nodes, we see that we have a list of 1 to 5. If we print nodes 0, we have the last one. If we print nodes 5, we should get an index out of range. And if we print nodes 4, we get 4. Great. Yes, so graph dot add nodes from nodes. Great. And let's draw it just to see what we have so far. Dual network graph, and this is how we have it. We have 5, 1, 2, 3, 4, 5 nodes. The font color can be improved. Font color equals white. And now we should build some kind of dependencies. So to say 1 can call 2, 2 can call 1, and vice versa, as this is undirected graph. I'll even write here undirected graph. Okay, how do we do this? We add edges. Let's put them here. Edges. And edges are tuples, so 0 to 1, and then 3 to 4, then 3 to 0, and then 3 to 5. Nothing changed. I just pressed Shift and Enter twice. Why did this happen like this? Because we haven't added the edges. So what we can do is like graph dot add edges from edges, and we see that everyone loves 3, no one likes 2. Let's put 2 and 0 together, and this should be the end of the story of our undirected graph. Now we flip the rules with a directed graph. So pretty much we can picture Twitter. You can follow someone, usually he doesn't follow you back, or if you are really famous, this is your case. The case is something else. I mean, someone follows you, but you don't follow back. So there should be a way to display this, and let's give it a try here with dgraph, pretty much. And dgraph, this is how we're going to call it. In the book I think it's something else, nx.dgraph. And now we have the nodes. Yeah, we can use the same. And then the edges, let's use the same. And now we named our graph dgraph, but we have also to include the nodes. This is usually what happens. And the problem is the following, that module network has no attribute dgraph. This is the case that we haven't added this thing here. Happens all the time. Module network has no attribute dgraph. Oh yeah, another thing. Mistakes all the time. And now let's draw it. NX draw NetworkX. I'm just pressing tab. Let's see. Yeah, okay. It will work like this. NetworkX graph and font color was white. And this is the same as this one because we printed the graph, but we should print the dgraph. And we see 240, is it correct? 240, yes. 0 false 1, of course. 340, 3 false, 3 false 5, 3 false 4. Let's make sure that everyone falls 0 and see how it will look like. Then 0 false itself. Yeah, 0 false itself. It's not written 340. It's written 3 times, but just with 1 arrow, which is okay. Yeah, let's put 1 and 4 in the picture so they're not feeling isolated. Yeah, and here we even say the small self-following. Okay. So far so good. This is all for directed graph and how to plot it. Now let's talk about multigraph. So what is a multigraph? A multigraph allows more than one edge between the same two nodes, and it is perfect for modeling train lines between same cities or multiple friendship levels in a game, in a way. Okay, so we'll be talking about multigraph. And this thing here was directed graph. So multigraph, and the first thing was undirected graph. Graph in Bulgarian is a count. So usually if you ask someone if he knows anything about graphs, they usually watch strangely about it. Okay, so let's go with multigraph, and it equals NX multigraph. Great. And if we say multigraph, it's some object already created. So the nodes would be the same, and the edges would be the same. And this one I'll copy, but somehow I'll say that and that. And then let's see what will happen if I say this. Nothing special. Simply gave me the nodes. Yeah. What else can I say? Let's see. NX draw network nodes graph, and we don't have the position. So the position should be defined manually by Kamada Kawai layout. Multigraph, and of course I'm using multigraph. Let's see. And the positions, what else? I'm just thinking. Okay, we have the X that should be written differently. And draw network nodes is missing one required position of argument positions. Oh yeah, pretty much this one. Yeah. Okay, we have something. It's a multigraph. We do not have the edges correctly. And the thing we don't have them is one of the problems with this library is that if it is a multigraph, we have to define them ourselves. So let's find a way to draw them. But before this, let's make this one a bit happier. So with labels, draw NetworkX edge labels, and it would be multigraph position, font color would be W. Yeah, something. And we already have here something saying what exactly is happening. And this is from the positions here. Or the exploding, let's see. No, it's not the exploding. It's not the positions. Is it the nodes? No. The edges? No. Yes, it is the labels. Okay, so these labels are drawn that way. Great. So let's add a few 1 zeros like this. And then let's see that for each graph edges we want to do something. So for each edge, or for my edge in graph edges, print my edge. Yeah, so this is what we got. Okay, fair enough, I would say. But in our case, it's multi-graph edges, so I'm expecting to see the 1 zeros more. Yeah, this is, what is the 0? It's a good one. Yeah, it's in 3 dimensions, and 0 is obviously the first dimension for multi-graph edges. Okay, the thing is that we should be doing something with that, and we should find a way to annotate it. So it's X annotate, and now the beautiful part of the code is going to be written quickly. So XY position equals a lot of stuff. So position equals E, XY coords is the data just written, then the text, then the arrow dictionary with the arrow style, and let's press Shift and Enter and see how it is going to happen. Yeah, this is what happens when you change something from the book. Name is not defined, so we go and we change it further, and this is what happened. Beauty. We see 1, 2, 3, 4 edges between 0 and 1, and they are here. It's 1, 2, 3, 4. Let's make them 8 and see how they're going to be displayed. I'm just curious. Okay. We can do it like even more. Let's abuse Okay, somewhere here, somewhere here, and somewhere here. Let's press Shift and Enter, and this is what we got. Yeah, plenty of edges between 0 and 1. Let's go within normal and see how it is going to happen. Tuple object is not callable. I have probably removed something quickly, so 0, 1, 1. Okay, here the comma is missing, and this is how it looks. Great. So after this one, let's go with creating an acyclic graph with NetworkX. So to create an acyclic graph, we pretty much need to create a direct graph. And what we're going to create is actually a direct acyclic graph, which is actually a tree. And the book says that a tree is a specialized case of graphs, a connected graph with no cycles or self-loops. Great. So let's try. I'll call this one acyclic graph tree. Great. And what do we do with this acyclic graph? Pretty much I'll call it acyclic graph, and it will be nx.dgraph. Pretty much the same as I think that one. Yeah. But it would have another bonus, and the bonus will be that we'll be able to check whether it's acyclic with code. So nodes, let's take these ones. Okay. Cyclic, okay, this one is deleted. Nodes, correct edges, acyclic graph, great. And let's see, nx draw network x acyclic graph nx dot kamada kawaii layout acyclic graph with labels would be true, and font color would be white or W, whatever you want to write. And let's write plt.show. Okay, well, it doesn't look acyclic to me, but let's say that we don't have to check whether it's acyclic or not. What do we have to do? Here we have that bonus called nx dot is directed acyclic graph, and we simply give this one and to say false. To make it directed acyclic graph, we should remove the 0, 0, I think. Let's try it again. And yes, now we have true. If you imagine 0 as a tree on the top, then it has 4 branches, to 1, to 2, to 3, and to 4, and that's it. What can we do as a further example? We can make 2 to be 2, 1. It's still directed non-cyclic, and we can give 1 to 2, and it will be false now. Yeah, fair enough. So far so good for the cyclic graph. This is how you display it. It's beauty, and you have this built-in check here for it. Now let's talk about hypergraphs. A hypergraph lets one edge to touch multiple nodes at once, and NetworkX fakes it with bipartite graph. So we have the edges of the red squares and white circles are ordinary nodes. Do we have real use cases? Well, we can have course prerequisites, multi-party contracts, but I'll just give another example. So we have import HyperNetX right here as HNX, and on the bottom we'll say data is something like this, and we have, let's say, 4 men called Ivan, who is good in football, in math, and in dancing. Great, good job for Ivan. And let's build someone else who is good, Peter, and we would have George. And we would have also, yeah, it's a Vitush Academy, so let's have Vitush. And Vitush is good in football, in maths, in dancing, in talking. You tubing. Okay, let's remove the football part, so it's a bit interesting. George will be good in dancing and in English, and Peter will be good in French, not in football, and just in dancing. Let's put here, for example, for Peter, Spanish as well. And let's put Spanish here as well. Let's see how it is going to look. So H equals HX and hypergraph. And we simply give the data and we say HNX dot draw and each. Let's see. And I have something extremely ugly, but I got this thing saying, okay, Vitush is good in dancing with everyone else. Then talking, then YouTube, then maths. Looks good. And if you are wondering how to disable the warnings, this is what I have done. I have said pip install shutup. You shouldn't be installing here within, but it works. Then import shutup place, credits to Stack Overflow. I'll simply write them. And yeah, shutup please. And now we have the multigraph without warning, and we see that everyone can dance because, yeah, obviously dancing is nice. What can we do? Can we do it a bit better? No, it looks okay. Let's see if, for example, we put something else here. We can say advanced French for George. So somewhere here, he used advanced French. Yeah, and every time you run it, it recalculates everything. So you see, you need a few runs just to have something that is readable, but it looks okay. And this import shutup is actually really helpful. Okay, so far so good. Let's continue with the last one, taught about weighted graph. And the idea of the weighted graph is pretty much, it's a directed graph, but it has weights because, for example, coming from 1 to 0 can cost $100, or can be 100 minutes. Coming from 0 to 2 can be only 5 minutes, and they shouldn't be the same. So what do? We say weighted graph equals nx.graph, and let's see, yeah, we have the beloved object. So let's start adding nodes, out node, and we'll use, in the example, it was written something about devices from the book, but in my case, I'll use something else. What would be it? Let's use Bulgarian cities. Yeah, Bulgarian cities sounds fine. Yeah. So node labels, or yeah, let's start with this. Bulgarian city Sofia. The position would be 0, 0, which is the first position. And then we have the other 3 Bulgarian cities. Yeah, the biggest 4, I guess, in Bulgaria. So 0, 0, 0, 2, 2, 0 for position, and then we have 2, 2. Great. Works. Let's continue. So adding the edges to the graph. Weighted graph dot add weighted edges from, and now the beauty. So from Sofia to Plovdiv, it would be 200. I think it's okay. Yeah. Then from Sofia again to Varna, it will be 450. These are not kilometers, these are something else. Can you imagine this? And then from Plovdiv to Russe can be 300. Okay, and now let's see whether it looks okay. Okay, great. The positions should be taken, so nx dot get node attributes, and we have the weighted graph and the position. Great, let's see how the positions look like. So Sofia, Plovdiv, Varna, Russe. Great, we have them. Let's draw the graph now. So nx do draw NetworkX. And it is weighted graph, position with labels would be true. POT show, let's see what we have so far. Well, something kind of ugly. Sofia, Russe, Varna. And I'm not seeing the kilometers here, which is bad. So we should add them. NX draw network edge labels, and it would be weighted graph, position, edge labels, UV, this is nested dictionary, the weight for U, V, D in weighted graph edges, data equals to okay, and somewhere there was a mistake. UV the weight true. It's like this. I said it's a nested dictionary, which means that it's up to here, and this one should be a tuple. Now, great. So we have Plovdiv, Russe, Sofia, and Varna. And it's not that ugly generally. Okay, in the book they have even made it a bit better. I'll save you some time and I'll make it better without coding live. So At the end, this is the code that makes everything better. I mean, what it does is actually offsetting a bit each one. Like Sophia, like Varna, like Plodif, like Russe. This, of course, can be done with a loop for each something in this one. Do this one minus the offset, and you have plus the offset, so these ones should go a bit to the left, some should go a bit to the right. Yeah. And let's press Shift and Enter and see how it looks. I don't like the gray color. I'll say blue. Yeah, not bad. Cyan. Yeah, that's probably a bit better. So far so good. Let's summarize what we have so far. So let's start with the recap. First, we have a few imports. Shut up and shutup.please. It's a great thing that I found in Stack Overflow. How to disable Python warnings. And then we have the undirected graph, which looks like this. And its idea is that edges go both ways. Perfect analogy is a mutual friendship or a two-way street. Great. Then we have the directed graph in our scenario looking like that. And pretty much arrowheads make direction matter. You can think of Twitter, or in our case, Twitter has a new name that I just forgot. X, yes. So you can think about it. Then we go to the multigraph, looking like that. And what is important is that with this one here, we are able to actually make some multiple one-way streets, so to say. Great for parallel train lines or multi-channel relationships. And what is important is to remember that we should have this one here, the loop, because otherwise the library hasn't thought that it's important to display it, and I guess they are correct. This is the way to go around, an easy one once you know it. Then we go to the acyclic graph, a tree. So here the idea is that a directed acyclic graph, pretty much a tree, never loops back, which is why schedulers and build systems love it. Yeah. So let's check whether it's a direct acyclic graph. It's true. And if we reverse pretty much 0 to 2, like this, and we ask it, is it a cyclic graph? It will say false. And it's fair. Then we go to the hypergraph. Hypergraph is pretty much explaining how a hyperedge can connect 3 or more nodes at once. And you can see immediately that everyone is good at dancing, of all the guys, George, Ivan, Peter and Vitush. And for example, Vitush and Ivan are good in maths, and Peter and Vitush are good in Spanish, for example. Yes. So finally we go with the weighted graph, which is an interesting one, pretty much saying that there are some points. Between the points there are edges, and there is a cost at the edge. For example, plotted to is 300, and if you make it a bit better, it comes like this. This has been achieved with the offset. So thank you so far for watching Vitush Academy. Enjoy the rest of your day and take care of yourself. Bye bye.